welcome to Lesson 4 in the After Effects Expressions training series. In this lesson, I'll cover expression control of text, as well as random numbers, and a lot of other cool things. So let's get started. Okay, so we got a lot of material to cover here, so let's jump right in and study one of these pieces here. And the first one we're going to take a look at is this blinking cursor that you see right here. Now, I know this isn't too terribly exciting, but this is going to introduce a brand new concept, and this concept is going to come up repeatedly throughout this series and throughout your expression programming career. And this is something called the if-else statement. If-else allows us to test for a certain condition. You can say, if this condition is met, then pass some sort of result. If that condition is not met, or else as we call it, pass a different result. Now, result 1 and result 2 are not necessarily limited to just, a single value. These could be multiple lines of code, and I'll show you examples of these. But this blinking cursor is going to use this if-else statement. So I'll create a new composition, call this cursor, blink, TV resolution is just fine, and I'm going to create some text here, / surveillance cam. Next, I am going to create a new solid. This is going to be the cursor, and this is going to be a 15 by 20 solid. Little light blue is just fine. Now I'll move this into place and hit T to show the opacity, and we're going to create an expression for opacity. What I'm going to do is declare a variable n equal to math.sine time. We remember this from last few lessons, actually. I seem to use this a lot. And I'm going to add a multiplier in here. So this is going to be creating an oscillating value. N is going to be oscillating from 0 to 1 down to -1 and back to 0. So what we're going to do is test to see if n is above 0 or if n is below 0. So in my expression, I'm going to say if, and then I need my condition. My condition goes inside parentheses. So I can say if n is less than 0, that is our condition. If that condition is met, then result 1 is going to become the value of our opacity. So result 1 is just going to be 0. So if we're saying if n is less than 0, opacity becomes 0. And if that condition is not met, if n is above 0, I need to type else, and then result 2 goes on the other side over here. So this is going to be 100. So if n is less than 0, then result 1 will get handed off to opacity, and it will become 0. If n is not less than 0, this condition is not met, then result 2 gets plugged into opacity. So if I drop out of here and if I play this, we'll see that our cursor is indeed blinking. Now, a quick word about if-else statements. As you start combing the internet and looking at other people's code, you're going to notice that it's not written so much like this, but something like this. Now, let me explain how we get to that from this. As I mentioned, result 1 and result 2 are not necessarily limited to just one line of code. They can be 1, 2, 3, 10 lines of code, or even more. So when we need to have more than one line of code, we need to drop these on different lines so we can accommodate these multiple lines of code. Now, a simple version of that would be like this. So we have our if, then we have our condition, and then we have code for result 1. And this could keep going for multiple lines until we get to the else statement, and then after that, we also have room for additional lines of code. However, programmers seem to like to put their result 1 and result 2 inside brackets. Now, this is an easy way to show you how the brackets are positioned at the beginning and end of result 1 and result 2. So this delineates where the result begins and ends. Same goes for down here. However, you're not going to see it so much like this, but you're going to see it like this, where the bracket for result 1 actually starts up here and then ends below the last line of code for result 1. Same goes for result 2. We have our result 2 starting bracket and then our ending bracket down here. So this leaves lots of room for resultant 1 and 2 to be as many lines of code as we need without any interfering brackets or anything like that. We can just see what the result is without any additional gobbledygook like these squiggly brackets. Now, if you need help visualizing this, think of it like this, where this red area would be all of result 1. We have our bracket and our code and our ending bracket. Same goes for here. We have result 2's starting bracket, the code for result 2, and the ending bracket. However, for simple if-else statements like this, one line is actually perfectly acceptable, but more often than not, if-else statements do span multiple lines for the results. And I want you to start getting used to this because you're going to see this a lot. Next, I'm going to create this circle segment design that you see right here. And we've got some type inside that is being dynamically driven by one of the circle segments. So I'll create a new composition. I'll call this the angle component. And I will create a new solid. Let's call this circle 1. And on this solid, I will apply the circle effect under the generate section. Now I want to set this edge to a thickness, and I'll set the thickness to 40. I'll set the radius to 200. Let me zoom out just a little bit. Next on this, I'm going to apply effect, transition, radial wipe. What I'm going to do is create an expression on the transition completion using wiggle. Now, wiggle, as you remember, adds variance to and from the existing value. So what I'm going to do is start this transition completion at 50%, and then I'm going to create an expression for the transition completion. So I can just do that by holding the Option or Alt key and clicking right there on the stopwatch, and we can see our expression down here. I'm going to type wiggle, and we'll have this wiggle 1 time a second, and I'll set this to a variance as much as 50. So it will vary 50 in either direction. Because this starts at 50, this will go as low as 0 or as high as 100. Now, I'd like to make a few duplicates of this that are all a little bit different in thickness and radius and start angle. Now, I could do this manually, but it's a series on expressions, so let's do this with expressions. To do this, we need to explore the random number generator within expressions and in JavaScript. Now, it's pretty easy. We can type the word random, and then in parentheses, we define our range that we would like to have our random values fall within. If I only specify one number, this random number generator will create a random number between 0 and 1. If I define two numbers, like -1 and +1, it will generate a random value anywhere in between -1 and +1. And notice it is not going to be a whole number. In fact, rarely is it going to be a whole number. If I were to define something like 20 and 100, the random value would fall somewhere between 20 and 100. Now you can see down here I've got this expression typed out, random 20, 100 in parentheses. And if I play it, you'll see that it's generating a random number on every single frame. Now, what if we didn't want it to do this? What if we just wanted one random number throughout the duration of our composition? Well, for this to happen, we need to rely on one other term other than random. We need to have something else, and that something else is called seed random. Now, before I describe what seed random truly does, let me just say this. Computers on their own do not have the ability to generate random numbers. They can't just say 7. They're machines. They don't have any imagination. So what they do is go through predefined lists of random numbers. So when we're using two sets of random numbers, we want to ensure that we're not using the same set of random numbers. This is common in particle generators and other effects, but in expressions, we have complete control over this sort of list that this random number generator is using. So what I can do in parentheses is type a number. And think of this sort of like a number of a list that it's using to start. So this could be random number list number 1. So that will have one set of values. If I change this to 2, This will have a completely different set of random numbers. Now, After Effects is actually pretty good about using different random number lists for each layer. However, if you are truly running into a case where you're getting a duplicate set of random numbers, you know where to go to change it. However, this isn't the main reason I bring up seed random. One of the most common uses for seed random is its second parameter here. So if I type a comma, we can control one more parameter within seed random. And this is something called timeless. Timeless can either be true or false. It defaults to false. So if I type false here, we're not going to see much of a change as this is the default value. Timeless says that this random number will generate on every single frame. So we're going to get a unique number on every single frame in our composition. It's going to keep generating every single frame. If I type true here, T-R-U-E, true, this means this is now timeless. This random value will not generate on every single frame. It will actually hold for the duration of the composition, which is pretty cool. An easier way to type true is just to type 1, as in 0 being false and 1 being true. So if I type 1, this will still be timeless. And this is how we hold values that we do not want to generate on every single frame. So what I'm going to do is copy this expression here and jump back to my angle component composition. And what I want to do is look at my circle, and I want to modify the radius and the thickness. I want a different radius and thickness every time I make a duplicate of this. So I'm going to paste that expression into the radius property here, and I'll have this be random between, say, 200 and 300. So every duplicate that I make is going to have a radius between 200 and 300. But because it is timeless, it will not change from frame to frame. The only thing that's changing right now is the wiggle that is on the radial wipe right here. Now if I go to the thickness and do the same thing, paste this expression, I'm going to have this be a random thickness between, let's say, 2 and 100. So it could be as thin as 2 pixels wide, or perhaps as wide as 100 on every layer that I make with this circle. So if I turn down the opacity so we can see these when they overlap, and I duplicate a few of these, we're going to see a lot of randomness in their radius and their thickness, which is pretty cool. Now I'm going to delete all of these except for one and type EE to show our expressions. Now, I think it's a good idea when we're using duplicate layers like this. We're hitting duplicate, duplicate over and over to get a bunch of variations on the same thing. I think it's a good idea to use index instead of a fixed number for the seed random. If we're going to be using it, we might as well ensure that we're going to get a unique random number list. So I'm going to type index in there instead of 2. So index is going to be different for every layer because every layer has its own number. Now, one more thing I want to change with this, in the radial wipe section here, I want to go to the start angle and make this change because, well, it's not doing anything right now. It's just staying put. Transition completion itself is moving around. And in fact, its starting value is 50, and it's moving 50% in either direction. Essentially, at some point, it's actually going to close up on itself. What I'm going to do is lessen this to 25. So it's never actually going to close up entirely on itself. Now, in the start angle, create an expression for that. And I'm going to create a wiggle for this. That's 1 time per second. Let's say also 25 in either direction. So the start angle is going to move around a little bit. But it's not a truly random start angle. It's going to be anywhere in 25 degrees in either direction down here. We need to have a truly random starting angle, anywhere from 0 to 360. So on top of that, we're going to add a random number generator. So I'm just going to copy one of these from up here, and copy, and push wiggle down a couple lines, and paste that little random number code. And we've got our seed random. We're creating a timeless value. And we'll make this random between 0 and, I'll just make it 180. So it's only going half a revolution here. I will add to that using plus symbol our wiggle. So now if I play this, our start angle is truly random. Now, The way to see this is by duplicating several of these. We'll see that the start angle is going to change for each one of these. Now, I'm also going to reduce this radius from 100 to 200 so they all are spilling outside of the screen. Duplicate a few of these. There we go. Make one more. We've got 8 of these. These are all truly random. And the start angle is random, the radius is random, and the thickness is random. Pretty cool. Hey, so remember what we were trying to make here? This was this thing here with the numbers that are moving around and the percentage symbol and all that. So let's finish this up. Let's get the text component done. So we've got our circle segments. They're doing their thing, and that's all fine and dandy. But what we need is our type. So I'm going to create some type with the After Effects type tool. And I'll just type some placeholder text. It says text. Now notice what happened when I created a layer here, all of my circle segments changed. Now the reason being is that we're using an index for our seed random. So this number here, index, changed when I created a piece of text here. To fix that, I can just drop this down below. That way index is not changing for any of these layers. Now I'm going to twirl open this text layer and go to the text property and look at our source text right here. This brings us to an interesting juncture on our path to learning expressions. Every other expression we've created in this series has generated some sort of numeric output. We've plugged it into a rotation value or opacity or whatever. Source text is completely different. Source text can work with all different kinds of values. Now, if I go into my source text here and I create an expression, just like way back in lesson 1, I can type 10 and the value becomes 10. I can type 10 plus 5 and I will be adding together the values of 10 and 5 and this will become 15. No big deal. However, I can type words in quotes like expressions. And the value of source text will become the term expressions. Any sort of non-numeric character like this is referred to as a string value. This is a non-numeric character. That said, numbers can also be string values. So if I type 10 in quotes, this is now a string because it is inside quotes. This is no longer the value of 10. It is a couple of characters that look like 10. So if I put 10 in quotes plus 5 in quotes, I'll have 105. This isn't a value of 105. This is just 10 and 5 added together. So these are string values stuck together. Now, nerdy people will say this is called concatenation, when you add together string values like 10 and 5. I'm just going to say they add together because it's easier to say add than concatenate. It's critical to understand this concept of string values, these non-numeric values, because we'll get into a lot of functions that require our type to be strings. So even if we're working with numbers, I will often, let's say if I'm working a calculation like 1000 minus 500, if I want this to become a string value so I can manipulate it using some expression terms that require our type to be strings, I will add an empty set of quotes. So this will be plus quote quote. One empty set of quotes back to back, and this will become a string value. Now, this expression will add this together from left to right. So this is a numeric value all the way up into the point where it hits this empty set of quotes, and now it is a string value. Now if I add to this something else like 5, because it's a string value, it's just going to concatenate the value on the end. I hope that makes sense. If it doesn't, rewind, watch this again. So I want the source text to be driven by one of these circle segments. So if I hit EE to show my expressions in here, I want it to be driven by this transition completion right here. So if I scroll down a little bit, I'm going to create an expression for this source text, and I'm going to pick whip this transition completion. And I'll close this back up. We don't need that. So right now, this number is being driven by
the transition completion of that layer. Now you'll notice how accurate our random number generator is. We're going to need to round this down just a little bit. This gets us into a lot of new terms. So what I'm going to do is declare a variable equal to all this stuff right here. So this number here, which is the transition completion, is going to be equal to n. Now don't forget semicolon. So now what I need to do is figure out how to round n. Now there's a simple term that we can use to round our numbers, and this is math, period, round. In parentheses, I can put the number that I would like to round. So in this case, this is n. So math.round n is going to round this value to the nearest integer value or whole number value. Now, like I said, I'd like to round this to tenths rather than a whole number. Now, there's nothing built into this function of math.round to specify the tenths or hundredths that we would like to round to. However, if I multiply this number inside the parentheses by 10, instead of being 59, this will be 588. What we can see is that 58.8 was getting rounded up to 59. If I multiply this by 100, we'll see even more accuracy. We'll see that it was 58.77 that was getting rounded to 59. So the easy way to fix this and adjust back to our original number is to simply divide this by that same power of 10. So in this case, I was doing hundredths, so we can see this is now 58.77. Or if I just want this to the nearest tenth, I can have it multiplied and then divided by 10. If we would like to make adjustments to the type size or typeface or the leading or tracking of the type, we will need to do that manually using the character window or using quick keys. Now, we use the After Effects type tool and click in our type layer, it will disable the expression and show us the original type that we typed out. And then we could select it and adjust the tracking manually using Option left right or Alt left right in Windows. This is why it's important to type a placeholder text that is a few characters long so you can manually adjust this. However, in expressions, currently in After Effects CS3, there is no ability to adjust tracking, leading, typeface, or anything of the sort with our type. Now, if I play through this, we're going to see an interesting anomaly. When it rounds it down to a whole number, it drops the decimal point because, well, it's 0.0, so to a computer, 56 and 56.0 are the same thing, so there's no need to put it. However, as designers, we'd like to keep this fairly consistent. So what we're going to have to do is test our number to see if it is coming out as a whole number or not. And if it is a whole number, we need to add back on a 0.0. So this is probably going to be some sort of if-else statement. If this is the case, do one thing, else do another. First of all, let's set this equal to a variable. We'll say r is equal to this rounded value of this number. Now we're going to create our if-else statement. If our condition is met, and I'll just leave this blank for now. We can come back to that. If our condition is met, then we will pass the value of r plus, and then quotes, 0.0. And then if that condition is not met, so we'll close result 1 with a bracket, and then type else, and then start result 2 with a bracket. And then we will have just the value of r. And then down here we will have the closing bracket for result 2. So the way I'm going to calculate whether or not a number is whole is by using an operator called modulus. Now, you've probably used modulus before, and you just didn't realize it actually had a name. Now, when you're way back in elementary school, you probably started out doing division using a remainder. Like if you divided 5 by 1, that was equal to 5, remainder 0. Or if you divided 4 by 3, that was 1, remainder 1. What you didn't know is that that remainder actually had a name. That remainder is called the modulus. So when we want to use modulus, we use a percentage symbol.
And if we were to take 5 modulus 1, this would be equal to 0, because 5 divided by 1 is 5, remainder 0. Now, if you're cool, you say 5 mod 1. So 5 mod 1 is 0. 4 mod 3 is 1, because 4 divided by 3 is 1, remainder 1. Even in the case of a decimal point, if we use 2.15 mod 1, the result is going to be 0.15. So you can see if we use mod 1, we can calculate whether or not a number is whole by looking at the result. If the result is 0, it's going to be an integer number. If it is not 0, then it is going to be a non-integer number. So if it's a non-integer number, we're just going to leave it alone. But if it is 0, then we need to add back on this string of 0.0 to compensate for this little anomaly, I guess we can call it. So let me show you how to do that. So we have already got everything else set up. The only thing we need to plug in here is our condition. What are we testing for? We're testing to see if r is an integer number or not. If it is an integer number, we're adding 0.0. If it is not integer, we're leaving it alone. So this condition is to see if it's integer, and we just learned how to do that. So that would be r mod 1. So if r mod 1 is equal to 0, then we will add 0.0 on top of r. If it is not integer, then just leave it alone. Just pass r as the value of the source text. Now, this all looks good and right, and you should say, yeah, that looks good to me. So if I accept this expression, we're actually going to get an error. Now, rather than explain what it's trying to tell you, let me just cut to the chase. A single equal symbol is only to be used in the case of declaring a variable. We are saying r is equal to this, or n is equal to all this. Down here, when we have a condition, this equal symbol is being seen by After Effects as a variable declaration. We're trying to set this stuff on the left side equal to something on the right side. And this isn't quite gelling with After Effects. It's saying, what are you trying to do? You're trying to set something in conjunction with a mod and setting it to 0. This isn't going to work. What we need to do when we're using a condition like this is to use two equal symbols. Just a JavaScript thing. Don't worry about it. So when we're using an if-else statement, and our condition is to check to see if something is equal to something else, we need to use two equal symbols. So this is still if r mod 1 is equal to 0. It's just that there is a specific case of using equals in a condition inside an if-else statement. Just something you got to get used to doing. So now this should work just fine. If I scrub to a point where right there, 57.0 was the result of 57. It saw that this was an integer number and then added back on 0.0. And then the other case where it is 57.7 just left alone because r mod 1 was not 0. Therefore, it said else just pass r, unmodified. Next, we're going to tackle this random number list that you see right here. It's going to touch on some old topics and introduce a number of new ones. So what we're going to end up with is a composition with a stack of numbers like this, evenly spaced, and we'll be able to define how many digits are in this random number. So let's say I wanted to generate a 6-digit random number. I would use a random number generator that would generate a random number between 100,000, which is the first 6-digit number, and 999,999. This would be the last possible 6-digit number. Notice I'm excluding anything from 0 all the way up to this number, and the reason is, to do that, it would be a lot more complicated, and honestly, you're never going to see the difference visually. And this is just a simpler approach to the problem, so this is the reason I'm going this route. Now, another way to think about this would be generating a random number between 10 to the 5th power. Remember this little caret thing pointing up is an exponent, so 10 to the power of 5. And then 10 to the power of 6 minus 1. Again, this number here is really just 1 million minus 1. So 10 to the 6 would be 1 million, and then if we subtract 1, that drops it down to 999,999. Now, in expressions, the way we express an exponent is by using math.pow, which is short for power. So we're raising something to a power. So we start with the first value in parentheses, then type a comma, and then put the exponent
or the power to which we'd like to raise the first value. So 10 to the 6 is equal to math.pow 10, 6. This will calculate 10 to the 6th power. Now let me move all this down, leave this in the frame for reference, and I'm going to put some placeholder text in here. I'm going to be using Courier because this is a monospaced typeface, and as these numbers change, we will not see any changing in their tracking or kerning. So I'm just going to drop some placeholder text in here called numbers, put that into place, and let's look at the source text here and create an expression. So I'm going to make this full screen here and myself some room to work with. So what I want to do is have a variable that I can use as the way to declare how many characters are going to be in this random number, how long the random number is going to be. So I'm just going to use the variable of length. And we'll set length equal to 6. So we're going to be making a 6-digit random number. Don't forget the semicolon. I can put a couple of forward slashes here and put a comment. So if somebody else to use this expression, they'll know what this was for. So this will be the length of random number. Not good at typing and holding a stylus in my hand. So again, 2 forward slashes allow for just a user comment. Everything after these 2 forward slashes on this line is just completely ignored. So next I'm going to declare a start and an end variable. These will be equal to something. Down here at the bottom, I will use a random number generator to generate a random number between the start and end values that I create up here. Pretty simple so far. Now, I have to remember to round this down because when we use random number generator, as we've seen, this isn't necessarily going to generate the cleanest numbers for visual purposes. So we have to remember to round this down. Now, I could use math.round and put this random number generator inside parentheses. But there's one problem about using math.round. Round will round this to the nearest integer if it's higher or lower. So in the case of something like 999,999.6, we have the very slight chance that we could actually round this number up to 1,000,000 and actually push this above our length, because round is just the nearest integer. It's not the nearest integer below or nearest integer above. It's just the nearest integer regardless. What I can use is math.floor. Math.floor rounds this number to the lowest nearest integer. And actually, you'll find that math.floor is more commonly used than math.round. Now let me open this up a little bit so we can see our little reference here. Now, I want you to know that 10 to the 6th is equal to 1,000,000. Now, if we count the number of digits here, this is actually 1, 2, 3, 4, 5, 6, 7. So note that 10 to the 6th power is one more digit than we're going to need. So in the case here of length is equal to 6, I need to use math.pow. It's fun to say, math.pow. And I'm going to use 10 to the power of length. However, I need to subtract 1 from length to get the right number of digits. So math to the power of length minus 1. So this would be 10 to the 5th power, which is going to give us 1 less digit than that. And that would actually give us the right number of digits. Now I'm going to have my ending value be math.pow 10 to the value of length. So this is going to be now 10 to the 6th. So we've got a range of 10 to the 5th and 10 to the 6th. So as I did before where I subtracted 1, I need to subtract 1 from this value right here. Now notice that where the parentheses are have a humongous difference on this. Here I am subtracting 1 from length, so that is to 1 less power. Here I am subtracting 1 from the total value of this exponent here so that this becomes one number less. Now I have to put my semicolon. Now if I look at this number up here, if I play through this, this is calculating a random 6-digit value. So now at this point I can go in here and change this length, and this number will change its number of digits to reflect what I put in here for the length, which is pretty handy. Now let's address the position of this. We'd like to have a number of these automatically distributing themselves in the y-axis. So let me get rid of these extra layers here and take a look at the position of this number here. So if I hit P, and I'll create an expression for the position. So let's learn a few more terms. I'm going to use n, and I'll set this equal to this comp dot num layers. This is equal to the number of layers in our current composition. Pretty straightforward, right? Just note the capitalization, lowercase n, uppercase L. This retrieves the number of layers in the current composition. H, I'll set equal to this comp dot height. This comp dot height is equal to the height in pixels of our current composition. And you might guess that this comp dot width would be the width of our current composition. You can find a number of these terms in the expression reference here under comp, and we'll see that we've got width and height and num layers. So these would work in conjunction with this comp to retrieve properties about this comp. So I'm going to space these out in the y-axis automatically. Now, that means I'm really just going to leave x equal to its existing x value. I'm not even going to worry about the x value. However, the y value, this is going to be equal to the height minus the height divided by the number of layers times the current number of layer. Now, just stare at this, and hopefully it'll start to make sense. If you think about this, I'm taking the number of layers and multiplying it by the current number layer and dividing that by the current height. So for every layer, this will get a unique position based on the height of the comp. So the first one is going to be right at the top. Now what I have to do is just pass off x and y at the end here. So this last thing in our expression becomes the values of x and y. I'll clean this up a little bit. I like to put spaces in between my variables. There we go. Now layer number 1 is at the very top. Layer number 2 is going to end up smack dab in the middle. Let me zoom out and duplicate that. It's going to end up right there in the middle. I make 4, they're going to space like that. And I keep making duplicates, and these are all going to keep spacing themselves out automatically like that. Now, you could use align and distribute if you want, but I kind of like this method sometimes when I want a specific list that I'd like to be able to perhaps add or subtract how many objects I've got in here to fill it up dynamically and not keep having to reach for align and distribute to redistribute these layers every time I make a duplicate. Next, I'm going to cover this scrolling code design that you see right here. This might be one of the more complicated pieces of this lesson, so don't be afraid to come back and watch this a few times before it really starts to sink in. So I'm going to create some text using the After Effects type tool, and I'm just going to put some placeholder text in here. I'm going to make this just a little bit bigger. I'm going to create an expression for this under the source text. And what I'm going to do is use something that we haven't done yet, but this should make perfect sense. I'm going to create an array using string values, so non-numeric values. Remember what string values are. They're non-numeric data, so they can have numbers, letters, whatever. So just like any other array, I'm going to start with the left bracket, and then I'm going to type out the contents of my array separated by commas. But in this case, I'm going to use words. So I'll use lions, tigers, comma, bears. Oh my. So T is equal to a 3-part array with individual components, just like any other array. Now, if I hit enter, what we're going to see as our type are the components of the array, and they're going to be separated by commas. Now notice, my commas in here are not inside the quotations. This is just a function of how After Effects type shows array contents. It just displays the contents separated by commas. We've not defined a specific piece of the array to be shown. It will show the entire array separated by commas. If I do define a piece of the array to be shown, like let's pull up just the first piece right here, lions, this would be 0, so T0 in brackets. This would just show lions. B1, tigers, B2, bears. Should make sense so far. If I'd like to cycle through these automatically, I'm going to set another variable equal to time, or at least for now. So n equals time, and tn is going to be this time value here. Now, this isn't going to quite work yet. Time is, well, it's got all these decimal points in here, and it's not going to really work the way we need it. We need to round this down. So I'm going to round it to the nearest lower integer using math.floor, floor of time. Now this is getting there. So it's going to go from 0 to 1 second, and then display the second piece, and then the third piece. And then once it gets above 3, well, there's not a fourth piece of this array, so it's just going to say undefined. So what we need to do is be able to loop this over and over, going from 0, 1, 2, back to 0, 1, and 2. What I'm going to do for now is put a couple forward slashes right here just to disable this piece of the expression. What we're going to see is what n is equal to, because this is the last part of the expression. It's now ignoring this down here. So we see that it's going from 0 to 1 to 2 to 3, and then 4, etc. Now, this is another handy use for modulus. If I use modulus, and then I use a number like 4, and the result is going to be a repeating set of numbers from 0, 1, 2, 3, and then back to 0. That is indeed 4 numbers, 0, 1, 2, 3. Now, if I go down here and enable this expression, I need to change this value to 3 because there are only 3 components to this array. So if I play this, we're going to have lions, tigers, bears, lions, tigers, bears, etc., etc. Instead of having a fixed value for this piece of the modulus calculation, what if we'd like to automatically figure out how many pieces are in this array? We can do this automatically by saying t length. This is just a variable, so I'm declaring a variable of t length equal to t period length. This will return the number of components of the array. In this case, it is going to be 3. So I have a variable of t length equal to t dot length. This is a variable t period length is going to be equal to 3 in this case. So put my semicolon. Instead of using a fixed value of 3, I'm going to put t length. Now this will automatically update itself. So if I scrub through this, this list will repeat from lions, tigers, bears, lions, tigers, bears. Now if I put something else in here, like, I guess, oh my, would be an appropriate fourth piece. This will now go from lions, tigers, bears, oh my, lions, tigers, bears, oh my. It's automatically updating itself because it's calculating the length of the array, which is very handy. So this method is very handy when we can go in and just manually type in an array like this, but it's not always going to be that easy. Let's say I had a humongous list that I wanted to deal with, like a big piece of code that I'd like to be scrolling on the screen. Before we go paste 200 lines of code in here, let's take a little more simple of an example. I'm going to create another text layer, and I'll just type lions space tigers space bears. So this is just regular old type that I've typed in and separated each one with a space. Now, I'm going to go down here to this expression, and instead of having this array here, I'm going to grab the source type of this layer above. So get rid of all this array here, and I'm going to pick whip the source text of this other layer. Now it's actually just moving through it letter by letter. This isn't very useful. But what I want to do, give myself some more room here. What I want to do is be able to break that layer up into an array automatically. Now there's a function that allows us to do this quite easily, and it's called split. Split works like this. I'm going to declare a variable called tSplit. And just like we did with length, length is a function that gives you the length of the array over here. This array was t. However, t is no longer an array. It's just some source text with some words and spaces in between. So split allows us to split contents into an array based on a character that we define. Every time it sees that character that we define, it's going to end one piece of the array and move on to the next. So t dot split will split the contents of t every time it sees a character that I define in both quotes and parentheses. The character that I'm using is a space. So every time it sees a space in t, is going to split it up into an array. So we'll have an array with lions in one component, tigers in another component, and then when it ends and comes to the end, this becomes the last piece of the array. So now we have tSplit equal to a split up version of this source type up here. So rather than taking the length of t, we need to take the length of this new array, which is tSplit. So now we have tSplit.length. This gives us the length of the array, which is 3. And then down here, this all works. But instead of t, which is up here, we need to use tSplit n. Now this is doing the same thing. And if I go in and manually change this, lions, tigers, bears, oh my. Actually, I need to put these together because it's seeing a space as a new piece of the array. So if I go through this, lions, tigers, bears, oh my. In this piece over here, you'll notice that we have individual lines floating by. So in the case of this, we had spaces, and these were pretty easy to find. What if this were a list of things like this, and I am hitting return every time I create a new line here? Now we have no spaces in here to look for, and you notice that our text is just one big block because it didn't find any spaces. What we need to do is look for a character of what we call a return, or carriage return as some people call it. Fortunately, in JavaScript, there is a character that we can use to define what a return is, and this is a \r. This is going to search for every return in this source text and then break those contents into an array every time it sees a carriage return. So this is going to do the same thing now, because it's breaking it into an array based on the returns at the end of the line. So in the case of our scrolling code, like I said, my source code is just going to be some Mel script that I found on the internet somewhere. Just a bunch of code looking stuff. So I'm going to copy and paste that into this source text layer. And I'm going to turn that off because we don't really need it visible. We just need it there as our source. Turn that layer off. Now, for this layer, I'm going to size it down just a little bit so it's not as big. And I'm going to make one modification to the code here, and that is n plus index. So each layer is going to be just a little bit different. So now if I make a few duplicates of this, duplicate that, move it up, duplicate it, move it up a little bit, duplicate it, move it up. Now if I hit play, we're going to see that this is scrolling, a little bit slow, but each line is sort of scrolling upward. So now we just need to adjust a time factor on here, and we've got time in here already. Let's have it go 4 times as fast. So if I rewind, we've got this scrolling code moving line by line. Kind of a cool effect. The one piece I haven't covered is this little motion tracker section right here. We've got X and Y data being mapped to some text that is rounded off to tenths. But you know what? You already know how to do that, so I'm going to leave that to you. If you need a little brush up on motion tracking, I've included one with this material that is using this video that you see right here. In our next lesson, we'll be covering how to do this scary looking title sequence. So I'll see you in lesson 5.